What if you stood face to face with a human from over 300,000 years ago? Would you be smarter, stronger, more evolved? Or would they surprise you? Today, we're diving into the incredible transformation of Homo sapiens. Our height, our brains, our bones, our bodies, even our temperature and the shape of our skulls. Some things got better, others, not so much. Welcome to our channel, where science gets personal and human history comes alive. Stick around until the end. You'll never look at yourself the same way again. Nearly 8 billion of us walk the earth today, and every single one belongs to the same species, Homo sapiens. We're the last surviving member of the genus Homo, still standing after nearly 3 million years of evolution. But our specific kind? We've only been around for about 300,000 years, a blink in cosmic time, yet long enough to change in ways few of us fully realize. In fact, when we compare ourselves to the first modern humans, the differences are far greater than most people think. Sure, some of the changes are barely noticeable, tiny shifts in our biology invisible to the naked eye. Others, though, are dramatic. And strangely enough, in some ways, we're more like those original humans than people who lived just 50,000 years ago. Take our height, for example. It's a common myth that humans have been getting taller over time. The truth? Height has been all over the place. For the past 100,000 years, we've actually been shrinking, and proportionally too. About 10,000 years ago, something big happened. Our average height dropped by 10%. Why? The shift to farming? Early agriculture led to limited diets and poor nutrition, stunning growth. Livestock also introduced new diseases, further weakening our bodies. Only recently, thanks to modern diets and medicine, have we started to grow taller again, reaching heights not seen since 9000 BC. But while we've been recovering our height, our bones tell a different story. Modern humans have much lighter, weaker bones than our ancient ancestors. In fact, today's bones may be just half as dense as they once were. Early Homo sapiens had bone strength more like Neanderthals, built to survive and endure. That strength gave us more power, more physical capability, but over time, we lost much of it. Why? Again, lifestyle's to blame. The first major shift came with farming. People no longer needed powerful frames to chase and kill wild animals. And in the last 100 years, things have gotten even worse. Sedentary life, office jobs, and modern comforts mean we move less, lift less, and stress our bones far less than we used to. What's troubling is that even active people today don't seem to recover the bone density of our ancestors. And while our bones have gotten smaller, our bodies have grown heavier, with global increases in BMI tied to diet and lifestyle. Now, here's where it gets really surprising. Our brains have shrunk too. Compared to the last ice age, the average human brain is now 12% smaller. That's 100 to 150 cubic centimeters less brain mass than our distant ancestors. And while scientists once debated whether this was even true, recent studies in 2023 and 2024 have confirmed it. Our brains really are getting smaller. Why? That's still up for debate. One theory, the self-domestication hypothesis, suggests that as societies grew, being docile and social became more important than brute intelligence. Just like domesticated animals, who also have smaller brains than their wild cousins, we may have traded brain power for social harmony. Another theory, the know-it-all hypothesis, says specialization reduces the need for individuals to know everything. You no longer need to hunt, make tools, and survive alone. Division of labor made it easier to outsource skills, and maybe over time, our brains adapted to this. But both of these ideas run into a problem: timing. The shrinking doesn't perfectly align with the rise of civilization. The most supported theory today is energy efficiency. Brains are hungry organs, just 2% of our body weight, but they burn over 20% of our resting energy. As the world warmed and temperatures rose, smaller brains may have helped our bodies stay cooler and more efficient. Still, no one knows exactly how this affects our intelligence. But some researchers warn that ongoing climate change, plus our growing reliance on technology, could further accelerate this trend. And while we're on the subject of brains, here's another twist. Their shape has changed too. Early humans had elongated skulls. Modern humans? Our skulls are rounder or globular, as scientists say. This change likely happened between 100,000 and 35,000 years ago. Why? Possibly to support bulging regions of the brain associated with planning, self-awareness, language, memory, and social skills. The stuff that makes us, well, Us. But it's not just our skulls. Our jaws and teeth have changed dramatically too. Over the past 30,000 years, our jaws have been shrinking, and not just compared to other Homo species, but even to earlier Homo sapiens. Why? Once again, diet. The rise of agriculture, processed food, and soft diets meant we no longer had to chew tough, fibrous meals. Studies show animals fed soft food also developed smaller jaws, and humans are no exception. Add that to our modern sleeping positions and softer beds, and you get weaker jaws and more dental problems. Crowded teeth, impacted wisdom teeth, misalignment, and sleep apnea. And that's not all. Even our body temperature is changing. For over 150 years, doctors believed that normal human body temperature was 98.6 degrees Fahrenheit or 37 degrees Celsius. But new studies suggest it's actually closer to 97.9 and dropping. In fact, we're cooling by about half a degree Fahrenheit per decade. Why? Fewer infections and diseases. Thanks to better living conditions, we suffer from less inflammation, which in turn lowers our internal temperatures. In short, early humans may have been warmer than we are today, and if technology keeps improving, we might even get cooler over time. But not everything has gone downhill. One change has been a huge win. We're living longer. In the Paleolithic era, the average human lifespan was about 27 and a half years. Today, it's over 73. That's nearly 3 times longer. This dramatic shift is thanks to healthcare, sanitation, and medical advancements, all powered by technology. Yet, as with everything, there's a cost. Modern life has brought new threats: vision problems from screens, cancers from pollution, and diseases like diabetes and osteoporosis. Many of today's health issues are directly tied to the very progress that helped us live longer. Still, one of the most fascinating transformations we've undergone is in our diversity, especially phenotypic diversity, or the way we look and function. Early humans were less diverse. They lived in smaller areas, had smaller populations, and faced similar environments. But tens of thousands of years ago, some groups began migrating out of Africa, driven by climate shifts and droughts. This led to a huge explosion in variation as humans adapted to dramatically different environments. Different skin colors, eye colors, hair types, face shapes, and body builds all emerged as responses to local conditions, like UV exposure, cold temperatures, and food availability. Blue eyes, for instance, may help with light sensitivity in northern regions. Straight hair retains warmth on the scalp. The epicanthic fold found in some Asian populations may protect against snow and glare. Some traits even evolved in response to sleep posture or nasal airflow. Some adaptations are incredibly specific. The Samabajau people of Southeast Asia, who live much of their lives diving underwater, have developed larger spleens, helping them hold their breath for up to 5 minutes underwater. Meanwhile, groups like the Tibetans have adapted to higher altitudes, with traits that help them thrive despite lower oxygen, including better hemoglobin efficiency, lower resting heart rates, and greater lung capacity. And yet, despite all this variety, Africa remains the most genetically diverse place on Earth. Evolution never stopped, and it's still happening, and fast. Take the sickle cell trait, a genetic mutation that offers protection against malaria. It evolved in West Africa just 7,000 years ago and is now found in up to 40% of the population in some areas. In truth, the first modern humans likely had their own oddities, features shaped by unique climates and genetics. And today, our DNA reflects not only our biology, but also a rich history of interbreeding with Neanderthals and other now extinct human species. When you look at the big picture, it's incredible how much we've changed. Physically, biologically, genetically, we're not the same humans who once roamed the grasslands of Africa. And perhaps the most profound change of all is how we continue to change, not through natural selection alone, but with the help of technology. We're the only species to colonize every climate, not by evolving, but by inventing. Our tools, machines, and digital lives shape our bodies and minds in ways evolution never anticipated. What does this mean for the future? Nobody knows for sure. So yes, we're all Homo sapiens, but we are far from what we used to be. Evolution didn't stop, it simply changed direction. Today, we're not shaped by predators or hunger, but by screens, cities, and convenience. And the changes? They're still happening. What will the human of the future look like? We don't know, but one thing is certain: they won't look like you. We're still evolving, just in ways we never imagined. So cross your fingers, and cross them tightly. If If you've enjoyed the journey through time and transformation, give the video a like, subscribe for more, and tell me in the comments which of these changes surprised you the most. Until next time, keep your mind open and your curiosity alive.